I welcome you all to this online tutorials. My name remains Matthew Ocheleka Itodo. I'll be taking you on biochemistry of homeostasis, and I'll be concentrating on water balance. And I want you to listen attentively as I proceed. This is what I want you to achieve at the end of this class. You should be able to list examples and explain homeostasis in human body. You should be able to explain medical and biological importance of water. You should be able to write the distribution of water in human body and how water is regulated. You should be able to explain factors affecting water intake and water output. And finally, you should be able to explain disorders of water balance. As a point of introduction, I believe that based on your previous knowledge, you might have heard about homeostasis. That homeostasis in a simple tense refers to ability of an organism to maintain a stable internal environment despite changes from the external environment. That is, the body have to be in a state of equilibrium to maintain the smooth running of the metabolic process within the body. And then, if we all agree that the body is made up of cells. If the body is made up of cells, means the body cells survive in a fluid medium called internal environment or milieu interior. That the body cell, they survive in a fluid medium. And so, I continue. I want you to listen attentively. This milieu interior or internal environment contains substances such as glucose, amino acids, lipid, vitamins, ions, oxygen, etc. They are all suspended in the body cell in human fluid. Listen as we proceed. I will go ahead to explain examples of homeostasis in human body. And this is what I want us to achieve at the end of this class. You should be able to list the examples of homeostasis in human body and then listen attentively. Some examples of homeostasis in human body include: 1. Temperature regulations. That when it is hot outside, our body sweat to cool down. And when it is cold, the body shiver to generate heat or to stay warm. Is a good example of what? Temperature regulations. 2. Blood sugar level. I know you have heard of what? Blood glucose level. So this blood sugar level regulations, that after eating, our body release insulin to help regulate the blood sugar level. That if the blood sugar level get too high, the body tries to lower it because of the help of insulin that is acting as a doorway that help the regulation of the blood glucose level by allowing the glucose to move into the cell. And if it get too low, which is the step of what? Hypoglycemia, the body try to raise it. Okay? So, I want you to listen carefully. The third one is what? pH balance. The body maintain a specific pH level. And you know that the normal physiological pH is 7.4. So the body try all its best to maintain this physiological pH. It will not allow it to move towards acidic, neither will it allow it to move towards alkalinity. It will maintain in a neutral point of 7.4. Water balance. The body try to regulate the water balance by controlling how much water is excreted through the urine and sweat that to make sure that we don't get dehydrated or overhydrated. And that is when two factors affecting it like osmotic pressures and antidiuretic hormones come into play. As we continue in this class, you understand how osmotic pressure and antidiuretic hormones are able to help in regulating water balance in the body. The next point is blood pressure regulation. This mechanism in the body help to adjust the heart rate and the blood vessel diameter to make sure that it keep the blood pressure within a healthy range. Okay? Listen attentively. We are moving ahead in this class. You know, I want you to know that in this point we'll be discussing water and life. I believe that you have heard that the earth is made up of 70% water, means the earth is occupied by water, which is about 70%, while the rest 30% is made up of solid land, than which is occupied by animal, man, and forest, and whatsoever. The same thing happened to human health, that in human being there is 30% of fluid, while 70% of human fluid in human being, while the remaining 30% are made up of solid. So, if body fluid is much in abundance than solid in human being, then what is the medical and biological importance of this body fluid, or the importance of this water in human body? One, this water is present in every cell, so it is the medium in which all cellular events occur. Means there is no any biochemical reactions that happen within the cell that is not in a fluid medium. Two, it requires for enzymes action and for the transport of solute in the body. If you are talking about solute, like now for example electrolyte moving across the semi-permeable membrane, it have the same size with the water molecules, and then it move along the cell membrane together with the water. So water is a medium, the channel for this solute to move into the cell and out of the cell. 3, water aid the folding of biomolecules like protein, nucleic acid. So we have if you have, for example, protein, we have a primary structure of protein, we have two secondary structure of protein, we have what? Tertiary structure and quaternary structure. And then you see protein foods based on the categories. All this is possible because of what? The presence of what? Water in these biomolecules. Okay? And the next one is what? Semi-fluid nature of the body is due to water. The body is not just existing in form of a solid or just only water, but it's in form of a semi-fluid nature. Okay? And this is only allowed because of the presence of water. And this water is regulated. This water is also help to regulate body temperatures. And I want you to listen attentively. We are proceeding. Distribution of water in the body. Note this, very important. About 70 kg adult male, a healthy adult male, weighing 70 kg, have 45 liters of body fluid present in the body. Out of this 45 liter, 30 liter is found in intracellular fluid, while the remaining 15 is present in extracellular fluid. And then in extracellular fluid, the water is still distributed, in which out of this 15 in the extracellular fluid, 8.5 form the interstitial fluid, while 3.0 is found in plasma, while 4.5 is in what? Form of what? Transcellular fluid. And if we are talking about transcellular fluid, we're talking about gastrointestinal tract, the skin, the nose, the viscous hormone, cerebrospinal fluid, synovial fluid, and the rest of them are the what? subunit of transcellular fluid, and they are made up of what? 4.5 liters. Okay, but in the case of some special, in the case of women and obese person and old age humans, there's a difference. So in a special case, fat is water insoluble. I just want you to know that. There are some special cases that there's varies in percentage of the amount of water in the body. What are these reasons? Fat is water insoluble. The water content of the body alter according to fat present in the body. Like now, for example, in obese people, water consistency is low in percentage. While in the lean people, water consistency is very high because of the fat deposited at the adipose tissue of the obese person and of the female subcutaneous adipose tissue. That fat is deposited, and because of that, there is less water in women and obese person compared to lean person. So I want you to listen attentively. Now listen to this. Look at this table and listen carefully. The daily water intake and water output of an adult. Look at it now. These are the 3 channels that water can enter the human body. Drinking of water. The food you are eating is made up of water. And then in your body there are metabolic processes. So water is formed. These are the 3 channels. So if you see per day you have 2,500 ml of water generated within the body in a day. And then look at the 3 channels that water can get out of the body through urine, skin, lungs, and fecal water. That is your waste through feces. Okay, and if you check it to about 2,500 ml, means the amount of water taken in a day is equal to the amount of water excreted out of the body. Okay, to make sure that the body is in the state of equilibrium. The homeostasis is in the state of balancing.